Now in this section, we're going to go through two different methods to prove mathematical statements, which are direct proofs and mathematical induction. But first, let's start defining what a conjecture is. Now, a conjecture is the equivalence of a hypothesis of a certain experiment you're conducting. When you conduct an experiment, you set a hypothesis and you work out through the experiment to end up proving that hypothesis true. Now, the conjecture for proofs is the equivalence for a hypothesis for experiments. So for mathematical proofs, we set a conjecture based on a given pattern for which we use a mathematical proof to prove that conjecture true. Now once we prove a conjecture, it becomes a theorem. Now, if we start with the first type of proofs, which is direct proof. Now what is a direct proof? A direct proof is simply a proof that uses mathematical properties or theorem straightforward without making any assumptions. Now, what is an assumption? An assumption is just something that you assume true in order to keep on moving with your proofs. So basically, a direct proof does not use assumptions. It just uses mathematical properties or theorem in a straightforward way without making any assumptions in order to prove a certain conjecture. Now, if we look at this next example on direct proofs, over here I need to use a direct proof to show that the sum of two odd numbers is always even. Now, in order to do that, we need to work with the general form of odd numbers because we cannot just simply use a few odd numbers that I add and turn out to have an even result. Because if it's true for a few odd numbers, it doesn't mean it's necessarily true for all odd numbers out there. So basically, what is the general form of an odd number? So we go back to the definition of an odd number. An odd number is simply an integer that you cannot divide by 2. So what does it mean that you cannot divide it by 2? It means that whenever you take that integer and divide it by 2, you always end up with a remainder that is equal to 1 when it's an odd number. So basically, an odd number is simply an even number, which we represent by 2n, because an even number can be divided by 2, so it's an integer multiplied by 2. So in order to get an odd number, we just add a plus 1 to it. So basically, the general form of an odd number is an even number, 2n plus 1, or we could also use minus 1. It doesn't really matter. So it's 2n plus 1, where n is an integer. So in order to prove that the sum of any two odd numbers is always even, we just take two odd numbers, 2n plus 1, and 2k plus 1, where n and k are integers. So basically, as you notice here, I've used two different parameters. I've used n and I've used k. Now for the second one, I cannot also use n, because if I use n, I'd be adding that odd number to itself. So basically, that's not what the proof really wants. I wouldn't be adding two different odd numbers. So I know that the sum of an odd number to itself is even, but over here I want to prove that the sum of any two odd numbers, whether equal or even, or whether equal or different, sorry about that, is always even. So over here, let's go back to our two odd numbers, 2n plus 1 and 2k plus 1. So if we consider their sum, 2n plus 1 plus 2k plus 1 is 2n plus 2k plus 2. Now, in order to prove that this is even, this should be divisible by 2, which means that we should be able to write it as 2 times an integer. Now, I notice that I have 2 as a common factor here, so I factor it out. I end up with 2 into n plus k plus 1. Now, n is an integer, and k is an integer, and 1 itself is an integer. Therefore, their sum is an integer as well. So this is an integer. So I have an integer times 2, therefore this is even. So basically, I have proved that the sum of any two odd numbers is always even.